This is the problem that we're going to do together. Y equals 2x squared minus 4x plus 6. Okay, now this is a type 4 problem, and you've already done one type 4 problem. This is under S3. You just need something, an extra page, maybe just make an extra page. I am, so all right. The difference between the one we did for warm-up, which is your proficiency type problem, and the one that you have to do for a 4 type, is for the 4 type you have to use completing the square to rewrite this in vertex form. Now, to remind us what vertex form is when you have an H and a K, and you have one pair of parentheses. So we're rewriting this to look like vertex form. This is our end goal here. Normally when we solve these, your equation is equal to what number? It's not usually equal to y, it's usually equal to 0, right? Because when we're solving it, we're looking to see where y is 0. Well, in this case, our goal is different, but we're going to use the same method. So with completing the square, what's my first step to completing the square? Let's ask a specific person. Christian, what's my first step to completing the square?
Minus the 6.
Subtract c, or move c to the other side. So we're going to do the same thing here. We're going to subtract 6. Notice the y stays. Okay, the y does have to stay when you're doing a type 4 because our goal is different. We're not trying to solve, we're just trying to rewrite it. Alright, then in completing the square, what's normally your next step? Divide everything by a. Now, when you divide everything by a, you have to divide everything by a. That includes the y. So I'm going to divide everything by 2. When I divide by 2, you get y divided by 2. I'm just going to keep that as a fraction. What's negative 6 divided by 2? Negative 3. 2 divided by 2 is 1. Negative 4 divided by 2 is negative 2. Okay. We haven't changed any steps here. It does look different, though, because we have the y, but that's okay. All right. We have moved c over. We've divided by a. The next step is to take half of b. What's my b value? Negative 2. So, half of negative 2 is negative 1. And then what do I have to do to that? Square it. More than one person can answer here, because I know more than one person knows this. Well, negative 1 squared is 1. And then I have to take 1 and do what with it? Add it to both sides. And so that's exactly what I'm going to do here. I'm going to add 1 to both sides. Again, this is exactly what we've been doing before, just normally we don't have that part of it. But it's okay to have it there, because our goal is different. Okay, this sets me up to factor the right-hand side. I'm going to simplify this a little bit. Negative 3 plus 1 is negative 2. When you factor the right-hand side, we need two numbers that multiply to get 1 and add to get negative 2. And those two numbers also have to be whatever half of b was. What was half of b? Up here. Half of b was negative 1. So negative 1, negative 1. Okay, so I can write that as a squared binomial. Now, normally at this step, once we've written it as a squared binomial, we square root both sides. We're not going to do that here because our goal is not to solve. Our goal is to get it to look like this. Well, I'm almost there. So, if we want it to just be looking at like a different type of quadratic, then my goal at this point, instead of taking the square root of both sides, is to get y by itself again. Because notice, in where I want to go here, the y is by itself. So I'm going to get y by itself. I'm going to add 2 to both sides to make that happen. And then what's the only other thing attached to y still? Yeah, it's being divided by 2. So how do I get rid of division? I multiply. So we're going to multiply everything by 2. When you multiply everything by 2, it cancels out the 2 here, which we want. So we just get y. And then when we multiply this parenthesis by 2, we're just going to stick it in front. Like that. Okay, so we just multiply them together. And then 2 times 2 is 4. And you're done. So the process is the same. You still complete the square. But when you get down to the point where you normally take the square root of both sides, instead you just solve for y. So it's the same process, just the last step is a little bit different. Okay? You'll get some practice on that today, but since you already have a couple of examples to work from, what I do want to make sure we talk about is this. And I don't think you've done any part of this yet in notes. So we're going to go through this together. This is an S4. Now, at the end of the year, just because I always do this project, at the end of the year we always do like group videos where we take some standard that we've worked on throughout the year that you have to know for your final, and you get to make a video on it. Now, this is the most popular one, so keep this one in mind when that comes, and this one always goes first, because it lends itself to some fantastic videos, because it's all about throwing stuff off of high places. So, all right, one of the main applications of quadratics has to do with motion of objects. We've done catapult stuff. This kind of applies to catapults too. We've already talked about one main application, which is area, because quadratics deal with area too. The most motion of objects through the air can be modeled by one of the following equations. I'll use this one. We're going to use some variables here. I am going to define the variables if you haven't seen them before. Make sure we're paying attention to the screen, not chit-chatting over there. Okay, so in feet, we have S of t equals negative 16t squared plus v sub o t plus s sub o. Now, when I say sub o, that's just like a different way. That's like when we did the point slope form and we had x sub 1 and y sub 1 in the formula. Just a different way to identify those. You use the first one if you're in feet. You use the second one if you're in meters. The reason we have two different ones, and all the variables are the same, the only number that changes is the one in front of t squared. But that's because when you're talking about heights, it's either measured in meters or in feet, and so you have to be able to work with both. Alright, so we're going to actually go ahead and define these variables. And I should say that the negative 16 and negative 4.9, those are based off of the effect of gravity, or the effect gravity has on the object. In feet, the effect gravity has on an object is negative 32, and this is half of it. And then the effect of gravity on an object, and you actually saw this in your catapult project, was 9.8 in meters. So half of 9.8 is negative 4.9. And the reason they're negative is because when you're talking about an object in the air, it's always going to be a parabola that opens down because you're traveling and then it's going to hit the ground again. All right, S of t. S of t is one variable. Yes, there's two letters there, but it's one variable. That whole value is the desired height of where you want the object to end up. So if we want the object to hit the ground, then that value would be 0. But sometimes we want to hit something else. So, all right, S of t is your desired height. What do you think t stands for as a variable? Time. Okay. Now this time can be in seconds or minutes or whatever. V sub o, what do you think the V stands for? Velocity. Good. V sub o means that you're looking at the initial velocity, or how fast the object was going right off the bat. then S sub O is my other variable. Notice that S was used for desired height. There's a reason they don't use H, but you won't need to know that until later. So S here also represents height. But what kind of height do you think it's going to talk about? Initial. Good. Now, sometimes you'll have seen this formula or these variables before in other classes. Does this look familiar at all to anybody? Okay. Well, it's okay if it doesn't. All right. When setting up your height models, you want to keep in mind two key things. Make sure you know what your variables mean. And make sure your initial velocity has the right sign. Normally, there's no mistakes in this except for those two things. And the biggest mistake that's made is people put the wrong sign on their initial velocity. Velocity is speed and direction. So, like a velocity of 42 means that it's moving in an upward direction because it's a positive 42, and it's going at a speed of 42 feet per second or whatever. If it was negative 42, what direction do you think it's going to go? Okay, positive is up, then negative would be down. Justin Lucas, make sure we're paying attention to the screen here. Okay. We have two examples we're going to talk about and set it up. Now, obviously, these are examples that I totally made up, but they get across using the height model and then practicing finding our answers here. Okay, Anna and Gabby are duking it out. They've positioned themselves on either side of the barrier and are launching chess pieces at one another. I should say that students wrote these problems about other students, obviously. Gabby really wants to hit Anna on the shoulder because Anna broke her favorite chessboard, so she launches her king piece into the air at a rate of 18 feet per second from a height of 4.2 feet. How long does it take to hit Anna's shoulder, which is 5 feet off the ground? And does the piece actually hit her if Anna is standing 13 feet from Gabby? How do you know? I want you initially to cross off that piece. We're not going to get into that right now. We're just going to answer the first question. Now, because this is talking about launching something through the air and hitting something, this is a height model problem. Now, you have two to choose from. You have the negative 16 version and the negative 4.9. Which one am I going to use here? The negative 16. And why would I use the negative 16, Kate? Yeah, if you look through your problem, all of your data is in terms of feet. So we're going to use that height model. So I want you to go ahead and copy it down without plugging anything in. Okay. And then we'll figure out what we know and what we can plug in from that data. All right, the question that it's asking me is how long? How long does it take? Now, when you ask somebody, how long does it take to get to so-and-so's house, what's usually the answer? A time answer, right? It takes me 15 minutes. It takes me an hour. It takes me whatever. So when a question's asked you in math where it says how long, that means it's asking you for time. How long does it take? Well, that's a time value. That means that I'm looking for t, which means I should have a number to plug in for every other variable. And we're going to see if that's possible. Okay, so let's start with s of t. S of t. S of t is my desired height. Lucas, what's my desired height? Where do I want this to hit?
5 feet.
5 feet. So 5 is my desired height. 5 goes in for s of t. The negative 16t squared stays as is because I'm solving for t, so I don't know what t is yet. My initial velocity, go with Adam Mitchell. What's my initial velocity? How fast is this going at that? 18 feet per second. And as a positive value or a negative value? Positive. Because hopefully she's not throwing it at the ground if she wants to hit her in the shoulder. Hopefully she's launching it through the air upwards. So you're going to have a positive 18. And again, the t stays because you're solving for t, so you need the t to stay there. And Danielle, where does this start? What's the initial height? 4.2. Shh. All right. We have a quadratic. This quadratic has decimals. It has big numbers in here. For example 3 and example 4, since this is practicing standard S4, we're going to be using the quadratic formula to solve these. So we're going to go ahead and write that out, because I don't think everybody has it memorized yet, so I want everybody to put it in their notes. We're using the quadratic formula to solve for t, to solve for my variable. And notice that my variable, instead of saying x equals, it's now t equals, because my variables changed. Now, before I actually start plugging stuff in, do I know what A, B, and C are? No, I have to move what over first? I have to move that 5 over. If you don't move it over, you don't know what A, B, C are, so you can't use the quadratic formula yet. 4.2 minus 5 gives me negative 0.8. Okay, and then we're going to plug in the numbers where they go. So negative b is negative 18, plus or minus the square root of 18 squared, minus 4 times negative 16 times negative 0.8. I know I'm going kind of fast. I'm just plugging numbers in. This is 16. And then it's all over 2 times negative 16. Okay. I want you to go ahead and simplify what's underneath there. You're going to get a decimal, but that's okay. But I want to see if everybody can at least get to that point. Simplify what's underneath the radical. There's calculators coming if you need them. I'm going to call on 3 of you here to see what you get. Again, you're just punching out what's underneath the radical. Do you need one too?
Yes, please.
Okay. I'm going to go with... Oh, people are still clicking away. I'll go with Desiree and Gwen. Can you guys give me what you both got? Just underneath the radical. You punched all that out? What'd you get, Desiree? Still working? Does anybody have what's underneath the radical? Date and mark.
Yeah.
What'd you get? Christian, did you have it?
Yeah, I believe I have it.
Yeah. Okay. You should have gotten 272.8. You did?
Yeah.
Okay, good. Okay, so 272.8, that's what's underneath the radical. Go ahead and write that down. Now, if you're not helping yourself out and practicing finding this, then you're not helping yourself out much, because this is a good opportunity for you to do it in class, where you can know if you're doing it right or not. Now, normally when I give a time, like if somebody asks me, what time is it? And I say, oh, it's whatever, 9:20 something. I normally don't say, oh, it's negative 18 plus or minus the square root of 272.8 all divided by negative 32. That's what time it is. Normally, that'd be weird if I said time that way. So, what are we going to have to do here to get an answer that makes sense to us for this problem? Probably punch it out to a decimal. Because if I said it took 3.2 seconds or 0.25 seconds, that makes sense to us in terms of how much time that is. So we're going to go ahead and punch it out. Now, I want you to I want us to think through this because we have two possible answers here. You can take negative 18 and add this radical, or you can take negative 18 and subtract. Now, in this case, I'm not going to punch out both. I'm just going to take negative 18 and subtract. Now, let me talk about why. I'm only going to do one. If I take negative 18 and subtract, no matter what that number is, it's going to be negative, correct? Okay? And I have a negative on the bottom, and a negative divided by a negative is a positive. Your answer for time should always be positive because negative time doesn't make sense. You can't go backwards in time. So, we have negative 18 minus the square root of 272.8. And you have to at least be watching here because if this is how you have to punch out on your own. I usually hit enter to get my negative decimal. And then I'm going to take that and divide it by negative 32. So this gave me the top. I'm going to divide it by the bottom, and I get 1.08 if we round up. Does that answer make sense for this problem? 1.08 seconds. Throw a snowball in the earth, throw a chess piece in the air and have it hit somebody. Yeah. So we're going to go ahead and write that as my time value. Time equals 1.08, and that's in seconds. And you're done. So the actual work that you have to do here is stuff that you have been practicing because it's just the quadratic formula. So the type 4 is setting up the problem initially and then making sure you can punch it out correctly. And we're going to go ahead and do one more together, and then you're going to get some time to practice on your own. Selena and Emily have decided to learn how to harpoon fish. They need to practice their skills, so they head out to a local barn and stand in the loft, which is 25 feet above the ground. They're aiming for a stack of hay on the floor of the barn, which is 2 feet off the ground, and they throw the harpoon at an average speed of 26 feet per second. How long does it take the harpoon to spear the hay? And then we will be able to answer that last question, but we're going to start with how long does it take? What variable am I looking for with that question? How long does it take? I'm looking for time. Okay, so I'm looking for t. Am I going to use the negative 16 version of the height model or the negative 4.9 version? Negative 16, because again I'm in feet. So I'm going to go ahead and write that out before I plug in anything. Okay. And then let's look at some variables. So now S of t. S of t is where I want this harpoon to end up. Justin, where do I want this harpoon to end up? What height? Okay, well, what am I aiming at? Look at. Okay, well, I'm trying to help you. Okay, so we have they are aiming for a stack of hay on the floor. What's the height of the stack of hay in that sentence?
2 feet.
2 feet. Good. So that's going to be my desired height here is just 2. Now you don't have to plug in 2 for time. You just have to plug in 2 for S of t. I'm looking for t. So that t squared stays as is. And then I'm looking for my initial velocity. Go with Megan. How fast is this going when they let it go? Okay, and now we have to be careful. Is this going to be a negative or a positive velocity? It's going to be negative because they're throwing it down. So when you put in 26, you have to make sure that's a negative 26. If you don't make it negative, it will change your answer, and it won't make sense. So just be careful there. And then my initial height. How high are they up off the ground when they throw this harpoon? 25 feet. So my initial height is going to be 25. Okay, so that's my setup. I'm going to use the quadratic formula here, so I'm going to go ahead and write it down again. But before I can start plugging numbers in, what do I have to do? Subtract 2. I got to get everything over to one side and get it equal to 0. So I'm going to subtract 2 from 25, and I have all my numbers. Now, I'm going to give you a minute to, on your own, plug in A, B, and C into the quadratic formula, and then we'll punch it out together, but I want you to take some time and put it into the formula yourself. So you don't have to punch it out, just put the numbers where they go.
Do you know that it's recording?
Yep. Those are some people that aren't here. So if you want to make it up, then they can make it up.
See? Hi, people that aren't here.
All right. Now, before you start punching it out to a final answer, I do recommend doing what we've done before and simplifying what's underneath the radical first. That will eliminate a lot of mistakes. So I'm going to punch out 26 squared minus 4 times negative 16 times 23. That gets me 2,148. But that's underneath the radical, right? So I can put that in. 26 plus or minus square root of 2,148, all divided by negative 32, if I simplify. Now, why is that 26 in the beginning positive? I thought it was negative b.
Because it's negative and a negative.
Yeah, negative and a negative make positive. So just watch that. And now, we're going to go ahead and punch this out. Now, if I have two options. I can take 26 and add the radical, or I can take 26 and subtract the radical. My final answer has to be positive because we're talking about time. If you take 26 and add the radical, automatically you're going to get a positive number on the top, right? So I'm going to take 26 and subtract the radical, and hopefully that gives me a negative answer on the top so that I can divide by a negative to get a final answer of being positive. So we're going to go ahead and take 26, subtract the radical, 2,148. And I usually punch that out. I don't divide it by negative 32 in that step because otherwise your calculator only divides the radical by negative 32 and not the whole thing. And now we're going to divide by negative 32 and you get an answer of 0.64 seconds. Is that a logical answer for this situation?
Yes.
Yeah, it is. Because you're throwing something pretty fast. So it shouldn't take you that long to hit it. So my time value is 0.64 seconds. Now, you need, since this is a real life situation where you have some units, you need units on your answer. Don't just write 0.64. Make sure you write 0.64 seconds. Yes, Megan? Yep. Okay. Once you've written what you need to there, I want you to go to iTunes U. And I uploaded a practice sheet. It says S3 and S4, 4 type practice problems. I want you to upload that into Note Taker and have it ready to go here while I give you new directions.